Hello, and here is my long-awaited and oft-promised session on rearranging equations for IGCSE Physics pupils. I know some of you are really happy doing this, but some of you have asked for a little extra support, so here it is. The rules for rearranging equations are simple. There are two basic things that we have to remember. And the first is whatever we do to one side of the equation we have to do to the other. You can think of an equation as being a set of those scales that you used in primary school, where you could put something in one pan and balance it out with something in the other pan on the side. So obviously if you take something off one side, then the scale will no longer balance. So to make it balance again, you have to take something out of the other side. And it's exactly the same with equations. You can think of them as being one of those balances. The second thing we need to know is that we have to know how to undo operations. Now in maths you probably know this as the inverse operation, or they might talk about taking reciprocals, but we need to know how to, we're just going to simply refer to it as undoing operations. So the first thing is, if we see a multiplication sign, we can undo this by taking the opposite action, and the opposite action to multiply is a divide. So we can undo a multiplication by dividing. If we see an addition, we can undo this by subtracting. And similarly, if we see a subtraction, we can undo this by adding. And obviously if we see a division, we can undo this by multiplication. So for each sign you need to know how to undo it, what its inverse operation is. Before we start with equations, I think sometimes it's the letters that upset people. Let's have a look at doing exactly the same thing with an equation that's based purely on numbers. So I'm going to have an equation that you can do in your head, and I'm going to say that 10 is 5 times my mystery number. So I'm not calling it x, I'm giving it a question mark, I'm just calling it mystery number. And let's say I want to solve this equation to find out what the mystery number is. That's what solving an equation is. It's finding out the thing you don't know. Well, the first thing I want to do is get my mystery number by itself. I want to end up with mystery number is equal to something. So then I look at my operation. Well, the thing that is operating on my mystery number is this times 5. So to undo the times 5, I need to divide by 5. So I'm going to divide this by 5. Then I go back to rule 1, and whatever I do to one side of the equation, we have to do to the other. And so I also have to divide this side by 5. Now you probably know from fractions and arithmetic that 5 divided by 5 just gives us 1. It cancels out. And so we end up with 10 divided by 5 is equal to 1 times our mystery number. Okay, so we don't usually write 1 times, we usually just write the number. And so now I can put this in the form that my mystery number is equal to something. I can just reverse this and say that my mystery number is equal to 10 divided by 5. So my mystery number is 2. So if we go back to our original equation, which remember was 10 is equal to 5 times mystery number, then we can see that mystery number is indeed 2. So when you're rearranging equations, this is exactly the same thing. All you're doing is using symbols rather than numbers. Sometimes, if you can't see how to rearrange an equation, try putting in some numbers. That used to work for me when I was your age, and then you can see how the whole thing operates. Okay, so you're thinking now, well, it's all very well to talk about rearranging numbers. We can see how that happens, but we're having problems when we've got symbols. So let's take an equation that both year 10 and year 11 know, and I wrote it down correctly already, that velocity or speed is equal to distance over time. So let's say, for this example, we want to end up, I'm going to write it over here, an equation we want to end up with d is equal to something. and we know it's going to involve D and T. So the first thing is to look at what operation is happening between D and T that we can undo. Well, D is being divided by T, and we know to undo a divide we need to multiply. Remember, in rule 1 we have to multiply both sides by T, so we end up with T times V is equal to this thing here. Now these two will cancel out and give us 1, and so we could rewrite this as B times T is equal to D, because B times 1 is just the same as B. And so if we want to write that in a nice form here, over here, we can just find out as B is equal to D times T. Remembering that we don't need to put the times sign in. If we just write the two symbols together, then that tells us automatically that they're being multiplied. Alright, let's have another go. You'll probably find that the method I'm using is a little long-winded, and that you'll be able to shorten it considerably once you understand what is going on and you feel a bit more confident. So we're going back to the same equation, and I use my pen tool. So that speed or velocity is distance divided by time. And this time I'm going to go for the harder of all three operations. I'm going to try and solve for t. So that means I want t is equal to something, and I know it's going to involve d and v. So if I want to get t by itself, I need to get rid of d, or I need to get t on the other side. So there's been a division going on here. So one way to look at it, and there is another alternative way of looking at it. One way to look at it is to say, well, if I multiply both sides by t, then I have this situation where I have d divided by t times t, and those will cancel out. And so I'm going to write it as v times t is equal to d. Now that's where I ended up before, and it's not really helpful because I actually want t by itself. So once again I have to go back to my rules and say, well, this t is being multiplied by v, and so to undo it I'm going to divide both sides by v. So this one cancels to 1, and so I end up with t is equal to d over v, which is the way that I wanted it. Okay, now it's your turn. So we're using the same equation. So v is equal to distance divided by time, and this time I want you to have a go by yourself at solving for distance using the methods that we used earlier. So we've done this once before. Let's see if you can do this by yourself. So restart the presentation as soon as you've solved this one. Okay, so what have we got? Well, we can see that d is being divided by t, and so in order to get d by itself we need to multiply both sides by t. So we end up with v times t is equal to d over t times t. Those two cancel out, and so we end up with d is equal to v times t. As you get more experience, you find that you don't need to take this step here, that you'll automatically think, well, I need to multiply both sides by t, so that will cancel. So it isn't absolutely necessary that you take this step. I'm just showing it to you whilst you build your confidence. Here is another equation, and this time I want you to try by yourself, and then I'll go through the solutions when you restart. So we've got year 11s will be familiar with this. So this is the power is I, stands for current, and V is voltage. But of course it doesn't really matter what the things stand for as long as you can manipulate them. So have a go at solving for I and solving for V using this equation. Well, this time I want to solve for I. So I want I is equal to something. Well, I have P is equal to I times V, and I notice that I has been multiplied by v, so I know that if I divide both sides by v, I'll write it out here, then the v's on this side will cancel and I will end up with I is equal to p over v. Now you don't really need to keep taking this step. As I say, you'll soon get to the stage where you'll just say to yourself, well, I know that that's going to be v over v, so that will cancel, and just do the operation on the other side of the equation. Do whatever makes you feel more confident and more happy. So in part 2, I'm going to solve for v. So I'll take my equation p is equal to I times v. So this time I want v is equal to something. Well, straight away I can see that v has been multiplied by I, and so to undo a multiplication I need to divide both sides by I. So on the left hand side I will end up with p over I, and on the right hand side I know that I divided by I is going to give me 1, so I can ignore that and just write the p. So I've missed out this step here. Well, I've not missed it out, I've just not shown it. So v is equal to p over I. So if I can write this in a more familiar form, v is equal to the power divided by the current. If you got those right, fantastic. If not, then just go back and review the earlier parts and see where you went wrong. I'm now going to use another equation that we use a lot in physics. Both year 10 and 11 should be familiar with this, and that is force times mass times acceleration, or force is equal to mass times acceleration, I should say. Don't forget that I don't need to write the time sign unless I really want to, because we know that it's there because the two symbols are next to each other. So a common one that we have to solve for is A. So for question 1, I want to solve for A. And then I would also, for question 2, I'd like to solve for M. So restart this presentation when you've had a try at those and then see how well you did. Right, so for question 1, I want to solve for A, so I want it to be A is equal to something. So the first thing I look and say, well, what is happening to A? Well, A is being multiplied by M, so I need to undo this multiplication and I'm going to do a division. So that means I'm going to, because I want to keep A by itself, that means I need to divide both sides by M. So that leaves us with F over M is equal to, well, I'm going to miss out the M over M because I know it's there and it's just 1 is equal to A. So that tells us that A is equal to F over M. So well done if you got that one right. Solving for M is a similar process. I want to get M by itself, so I want M equals. So I notice once again that M is multiplied by A, so to get M by itself I need to divide by A. So dividing both sides by A gives me F over A is equal to M, because on this side the A's cancelled out. And I can rewrite that if I like as M is F over A. So you can see that if we're just using 3 variables, it's easy to undo divisions and multiplications. I'll come back with another session on slightly more difficult equations as the need arises as we move through the course. So I hope you found this useful, and please let me know if there's anything you don't understand. Bye for now.